So now I want to see how we can represent inequalities in a Cartesian plane. Okay, so in this video I'm going to show you how you can effortlessly plot the graph of inequalities that involves two variables. Okay, so let's go without wasting time. Now we are given these inequalities. We are given this, and this. Now the first thing we're going to do is that we are going to get the boundary lines. Okay, after the boundary lines we now get the intercepts. Now the boundary lines is simply that you change each of the inequality symbol to equations. Okay, so let's do that. So for this, I want to get the boundary line. For this, my boundary line is x equal to -3. I want to get the boundary line for x plus y less than 3. So I want to get the boundary line for this. The boundary line is going to be x plus y equal to 3. Now if I want to get the boundary line for x plus 4y greater than 8, the boundary line for this is going to be x plus 4y equal to 8. Now the boundary lines are just, we are changing these inequality symbols to equations. Okay, now what this boundary line, what it does is that it helps us, it shows us the demarcation between the required region and the rejected region. Okay, so let's go ahead. Now we're also going to use this boundary line equation to get the intercepts. So let's get the intercept now. Now this is already x equal to -3, so this is an intercept already because the line will pass through this point. Now let's look at this other one. We can get the intercept for this particular boundary line here by saying let x equal to 0 to get the intercept for y, and we'll say when y equal to 0 to get the intercept for x. So when x is equal to 0, y is going to be 3. And when y is equal to 0, x is going to be 3. So I've gotten the intercept. Now this intercept will help us to know where this line, where this equation line will pass through. Okay, now let's come to this. If x is 0, we are going to be left with 4y equals to 8, and therefore our y will be equal to 2. If y is 0, my x is going to be equal to 8. So I've gotten the intercept for this. Now the next thing I'm going to do now is that I'm going to plot this on a graph. Okay, now so this is our graph. Now let's plot these points. The first one, which is x greater than equal to -3, our boundary line is x equal to -3. So let's go to x equal to -3. Now we are going to draw our boundary line to pass through this point. Now because this is greater than or equal to, we are going to use a solid line. We are going to draw a solid line to pass through that. Anytime you have greater than or equal to or less than or equal to, always use a solid line. Okay, so whenever you have less than or greater than, you use a broken line. Whenever you have greater than or equal to or less than or equal to, you use a solid line. Now let's look at that. This, they say greater than, so which means that these are the areas that are greater. So this is our required region, so we don't need this other region, so we are going to shade off these other regions. So remember, this is our boundary line. As I said earlier, our boundary line gives us the demarcation between the accepted region and the rejected region. Okay, so our boundary line here, these are a line for x equal to -3. So this is that. Let's go to the next one. The next one is this inequality, and the boundary line is this x plus y equal to 3, And to do that, we are going to use these 2 points, these intercepts, to know where this line passes through. So at y equal to 3, that's this point. At x equal to 3, that's this point. So which means that our line will pass through these 2 points. So let's join it. Now let's check the inequality that is there. This is less than, so we're going to use the broken line to pass through these 2 points. So let's do that. We're going to draw a broken line now. So these are broken line. So this is our line. This is the line for for x plus y equal to 3. So these are boundary line. Now let's check. If you check this is less than. Now let's check the path to accept and the path to reject. If x is 0 and y is 0, we're going to have that 0 is less than 3, and this is a valid statement, okay? Which means that the region where we contain this origin where x and y is 0, so this is our accepted region. We are going to reject this other part, so I'm going to shade this other part. This part is rejected, okay? It's rejected. So we are done with this part. Let's go to the last one. The last one is x plus 4y greater than or equal to 8, and our boundary line is this. Now the point is at y equal to 2 and at x equal to 8. So let's go y equal to 2, that's here, and then we'll have x equal to 8, that is here. So this means that our line will pass through these 2 points. So this is greater than, so we are going to also have a broken line passing to that point. I'm going to have broken line. So as usual, this is our boundary line. Our boundary line for this is x plus 4y equal to 8. Remember, I said that the boundary line of this is the demarcation between the accepted region and rejected region. Now let's check this. How valid is this? So if x is 0, remember we always use this origin because this is the point, this origin here is where x is 0 and y is 0, okay? So if x is 0 and y is 0, that will give us 4 times 0, 0, and having 0 is greater than what? 8, okay? So, and this statement 0 is greater than 8, this statement is invalid because 0 cannot be greater than 8. So if you look at that, means that this region that is towards this origin here will be rejected because this statement here is invalid. So to reject this region, I'm going to shade everything, all this region below the line towards where this origin is. So I'm going to delete, I'm going to reject them, okay? I'm going to reject them. And if you look at this graph, you can see now that the solution, the area that represents the solution to this graph is this unshaded region. Okay? So this is our solution. This point here, this region here is our solution. So thank you very much for watching. I hope you've gained value. Please kindly like and follow, and have a pleasant day. Bye.